Hi everyone and welcome to my channel. This video my topic is differentiation and the subtopic is really rates of change. I did a separate video on this because students tend to find this topic is a little challenging, so I wanted to do a special video just to focus on this, right? This is covered in AdMaths and it can be done in Form 4 and Form 5 depending on the school. So please stay tuned to see what I have in store for you. So with rates of change, it simply means it's the rate of change of one value with respect to something else. So as you would see in my examples, there are various variables, and from just looking at these variables, we can figure out what are we really differentiating. With differentiation, we usually use the y, the x, but with rates of change, we will have all sorts of other things. We'll have the r, the t, the a, the r, etc. All sorts of things. So we need to get accustomed to this sort of format. So let me move to my first example. In example 1, it says the area of a circle is increasing at a constant rate of this. Now just this by itself, guys, is telling us so much. Firstly, we're talking about a circle and we're talking about area. So what we always have to bear in mind is all these little pieces of information. So I'll just write it out. The area of a circle is pi r squared. Nice. So I just have that down. But in this first line, we're not talking about that. We're actually talking about the area of a circle is increasing at a constant rate of this. Looking at this here value 1.5 with respect to this is actually so important. This is telling us centimeters squared is area, right? And second minus 1 simply means time. So this line of information is really telling me the A dt, which is the rate of change of area with respect to time measured in seconds, is 1.5. So that is our first line of information. Now in our second line, it says find to three significant figures the rate at which, listen to this, the radius of the circle is increasing. So we want to know now the rate at which means we need to know dt, that's the rate, because they want to know at what, we're measuring time then, is the radius increasing. So what are we putting as our numerator here? It will be the r, because it's the rate at which the radius, so it's the r over, well, the dt, is increasing when the area is 2 centimeters. So we need to find this when area is 2 centimeters. So that is really our sum. So how would I proceed with this? Well, I have a nice piece of information here. 1.5 is dA dt. And from this here, which they didn't even mention this to us, we're supposed to just know to write this down, that area is pi r squared. I can actually differentiate this line with respect to the variable that it's written in, r. So differentiating this now, using pi as a constant, I will get 2 pi r. So this is the a, the r. Now I know this and I know this. And I need to find out, this is sticking a little bit. Right, I need to find the r dt. So ironically, the r dt actually be found by using these same two pieces of green circles here, which will actually be, what would that be? The r dA by the a dt. Now, I don't know what the r dA is. I know what the a dr is. So obviously, for me to get the r dA, I have to flip this. So it'll be 1 over 2 pi r, right, multiplied by dA dt, which is this 1.5. Now working this out, I will end up getting 0.75 over pi r. Now this gives me my answer with respect to r, right? But they didn't ask for that. They said what is the rate of change of the radius when the area is 2. So we have an additional piece of work to do. So let's work that out. If my area is 2, that means pi r squared is 2. So I need to find what my radius will be. So obviously I will send over all these, send over the square, and I'll get the square root of this, and that works out to be 0.798, right? Now that is my radius. Now I need to put that in here. So I'll get 0.75 over pi by 0.798, and simplifying that, get 0.3. Now we were asked for radius with respect to time, so I'll put cm per second. So this, everyone, is my answer. Now let me move on to my second example. question, they tell us that the volume of a liquid container is this, right? And they say they want us to find the VDH when H is 0.6. Now, let's continue with this. So if I know that V is 2 plus 2h squared plus 4 raised to the power of 3 on 2 minus 8. Then I could find the VDH, which is just simply differentiating this. Now this is really a value raised to power, so that's kind of like similar to this rule here, where I have something raised to the power of n, and the differential is usually n by the differential of whatever is on the inside multiplied by the same expression raised to the power of n minus 1. So following that format, I'll get 3 on 2 by the differential of the inside here will actually be 6h, because that's just the differential of 3h squared. Then I'll write back the 3h squared plus 4, and then I'll lower this value. 3 over 2 will be 3 over 2 minus 1, which will end up being a half. And well, of course, the differential of minus 8 will be 0. So simplifying this now, I will get, this will cancel here, 3. I'll get 9h by 3h squared plus h to the half, which is the same as writing 9h by 3h squared plus 4 square root, right? So that is the VDH, but now we need to find out when h is 0.6. So I need to put 0.6 there. So I'll get 9h, well, I can actually write it on this side, 9 by 0.6, root of 3 by 0.6 squared plus 4, and simplifying this, and that would end up being 12. So that is the answer for my first part. Now let's move on to the second part. 2, they say liquid is leaking from the container. It is observed that the depth of the liquid is 0.6. So let's call the depth h, right? The depth is decreasing at a rate of this. Now that means the h, the t, right? That's what it means when they say talk about the depth is decreasing at a rate, right? Will be minus 0.15 meters per hour, right? So I will put the minus in because it's decreasing, right? Find the rate at which the volume of the liquid is decreasing at the instant when the depth is 0.6. So find the rate at which the volume of the liquid, so what we're asked for in this one, the VDT, right? When the h value, which is the depth, is 0.6 meters, right? So how do we do this now? We know this value here, and we also knew what the VDH is when h was 0.6. It ended up being 12.17. We need to find the VDT. We know what the VDH is, so we could use the VDH. We also just found out what the HDT is, so we could use this too. When we cancel these two, we will get the VDT. So then that simply means I'm multiplying this 12.17, which was the answer from the part 1, that's the answer from here, and we multiply by minus 0.015, and that will give me 0.18 centimeters cubed per hour, right? Now negative, of course, or I could say the VDT is decreasing at a rate of 0.18, or the VDT is minus 0.18 centimeters cubed per hour. Either way, my answer is correct. Now let me move on to my third and final example. Now this diagram shows us a cylindrical water tank. It has a diameter of 6 meters, and water is flowing in the tank at this rate, and also what they said that water is leaving at this rate. So what's happening here? We have two things that are happening. Water is coming in and water is also coming out. So what we use is we say that because we have meters cubed per minute, this simply means it's the VDT. So since water is coming in, we'll put the VDT is equal to 0.48 pi, and that's coming in, so it's a positive. And since it's leaving at this rate, I will minus 0.6 pi h. So this is actually, this whole expression here will actually be my dVdt, right? Now in this particular question, they are asking us to prove this. So we have a little work to do still. Remember, one key point in doing any rate of change question is always observing the shape that you're dealing with and all the other formulae that will come at you with respect to that shape. This shape here is a cylinder, and they're speaking about volume coming in, volume coming out. So that is telling me, giving me a trigger that I need to work out what is the volume of this cylinder, meaning I need to state what is the formula. This, pi r squared by h. So I could then differentiate this, but in this formula, I have two variables. I have r and I have h. What would I differentiate with respect to? Will I go dv dr or will I go dv dh, right? Now, in our solving question here, we have the h dt. So that is kind of giving me a hint that perhaps I should do differential with respect to h so that I could get an h in my value. I could get a dh here. So now differentiating this with respect to h, I would simply get pi r squared, because this r squared is just treated as a constant and the h is really h to the 1. So differentiating this would end up being, well, just 1. So this is my dv dh. Now, since I have dv dt and I have dv dh, I could then manipulate and get the h dt. So let me do that now. The h dt will actually be, what would that be? The h dv by dv dt. Hope you all agree with me. I will be cancelling the two dv's here. So what is my dh dv? Well, simply it will be the inverse of that value, right? So that would be 1 over pi r squared, and I'll multiply by dv dt, which is all of this, right? Now, this is actually the h dt here, right? So now, continuing with this now, I would say, in my shape, I have my diameter is 6. So that means the radius here is actually 3. So I will write 1 on pi by 3 squared multiplied by 0.48 pi minus 0.6 pi by h, right? Now, substituting here now, I will end up getting 1 on, well, I don't need to put a 1, I'll put 0.48 pi minus 0.6 pi h all over 9 pi, right? Now I could factor out the pi's here and also 0.6. So again, I just put in the h dt on the side. So I will end up getting 0.6 pi by 0.8 minus h all over 9 pi, right? These two pi's will cancel, right? And if I take this 9 and send it over here, I'll get 9. The h dt is equal to 0.6 by 0.8 minus h. Now, that's pretty close to what I have here, right? Meaning I have a value, I have the h dt is equal to some value here and a minus h. Now, for me to get, I have a 9 here, but if I had to get a 75 instead, I would actually have to divide by 0.12. And how did I get that 0.12? Well, I simply took 9 divided by 75. This value here divided by the 75, and I got that 0.12, right? So now what I will do, I will just simply write back this here, and I will multiply this side here. So this will multiply here, right? And I will end up getting 0.48 minus 0.6h. Now if I divide the 0.12 here, here, and here, I will get 75 dh dt. 0.48 divided by 0.12, sorry, is 4 minus 0.6 divided by 0.12 is minus 5 each. So everyone, I have proven the proof, right? We got it. So we write hence proof. Now, I don't know about you guys, but this to me is a lot more challenging than regular differentiation questions. But I hope that these 3 examples that I did would help you all in some way to not give up with this topic. This is a topic where lots of marks are loaded into it, you know, but it's a matter of interpretation. So I hope that this video has helped you, and if it has, well, please feel free to like it, share it, and subscribe to my channel. Thanks again, guys, for tuning in.